Homework 3.1, Quadratic Functions, Video 2. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. Before we begin this next video, I want to point out that in the previous video I neglected to mention that homework questions 1 and 2 are associated with the contents of the previous video. Again, that's homework questions 1 and 2. What you're about to see now is associated with homework questions 3 and 4. So we're still talking about the vertex of a parabola, but quadratic functions don't always look like this. In fact, when we've seen them in the past, they typically look like this, something x squared plus something x plus something. And if I had to give this form a name, it would be called general form. And again, general form is any form that lacks parentheses and everything's just crammed over to one side. In lines, general form is fairly useless, but in quadratic functions, we encounter it quite a bit, and it's not nearly as bad. But how do we find the vertex? Find the vertex of f of x equals x squared minus 6x plus 8. Well, in the previous video, if it looked like this structurally, we could just pluck out two numbers, change the first one's sign, and boom, we have the vertex. Well, we have a problem. This function does not have this form. This form is a number times a squared parentheses, and there's only one x term. This has no squared parentheses, and there are two x terms. So before you start thinking it, don't just grab these two numbers and change the first sign. That's when you look like this. I don't look like this. This has parentheses and one x. This has no parentheses and two x's. So we could try to make it look like this. And it's not really that impossible. We would have to do a little bit of completing the square. But instead of doing that, I want to see if we can find the vertex by connecting this to something that we've seen in the past besides completing the square. We could find the intercepts on this. The y-intercept wouldn't be that bad. We don't really need it to find the vertex, but to find the y-intercept, remember the y-intercept is on the y-axis, which means x equals 0. So I could just put in x equals 0 and see what I get. Well, that's easy. Everything disappears except the 8. So I know this parabola would have a y-intercept of 8, but let's see if we can find its x-intercepts for a moment. If you're an x-intercept, that means you're on the x-axis, which means you did not move up or down, which means your y-coordinate is 0. Well, in a function, the y-coordinate is what comes out. So in order to find the x-intercepts, we need to know what do you put in order to get 0 out. In other words, we have to solve x squared minus 6x plus 8 is equal to 0. I'll save you the trouble. Well, first I'll invite you to pause the video and see if you can solve this. Feel free to use the quadratic formula, but this does factor nicely. If you're going to pause the video, you should do it now because I'm about to give you the two solutions. You've been warned. The two solutions to this equation are x equals 2 and x equals 4, which means at 2 on the x-axis and 2 on the y-axis, the graph crosses the parabola has its x-intercepts. Did you need it?
No.
Oh, okay, thank you. Sorry, folks, just checking to make sure everything's cool. Everything's cool. All right, so we've got the x-intercepts. There's two of them. We've got the y-intercept. We don't have the vertex, which is the thing that we're looking for, but don't worry, we're going to find it here in just a moment. I can kind of see where this parabola is. And also because the leading coefficient is positive, I know that it's going to open upwards. So I think with what we have here, I can go ahead and sketch a pretty rough draft of it. It's got to hit both intercepts. At some point it's got to turn around. That's what we're looking for. So let's use a little bit of intuition, if we will. We know it has an x-intercept at 2. We know it has another x-intercept at 4. Now, one thing about parabolas is that they're symmetric, or they have a line of symmetry. You can drop a line straight down the middle of it, which would go through the vertex. And the left half is a mirror image of the right half. So, if the vertex is right down the middle, and the intercepts are at 2 and 4, what do you think the x-coordinate of the vertex is? It looks like it's 3, and you would be right. So, how can we get the 3 from the 2 and the 4? I know 3 is the number right between 2 and 4, but let's say instead of 2 and 4, it was 5 and 19. How can you find the number right in the middle of 2 others? This sounds a lot like midpoint, which was in the previous series of videos. If you want to find the number between 2, you can just average them. So one way we can say that we get the 3 is that 3 was the average of the 2 x-intercepts. If I add 2 and 4, I get 6. Half of 6 is 3. All right, let's go with that for a minute. The vertex is at x equals 3. And again, we're conjecturing that it's 3 because it was the average of the x-intercepts. More on that in a moment. And y equals, oh yeah, this is a function. I can just stick in my x to get my y. So we can plug in 3, and this will take a little bit more figuring. 3 squared minus 3 times 6, minus 6 times 3 plus 8. 3 squared is 9. 6 times 3 is 18. And if we go 9 minus 18 and then plus 8, I believe we get negative 1. Which seems to make sense. It's about right there. Okay, so that's cute and all. And it's correct, by the way. But how would we do this generically? In other words, how would we come up with a formula that says this is where the vertex is? Well, in this specific example, we found the x-coordinate by averaging the x-intercepts. That seemed a good idea. It is. But how can we represent that generically? I know what happens after that. Once we get the x, just stick it in your function and out comes the y. But how can we generically say, find the average of the x-intercepts in a scenario like this? Well, I'll show you. Warning, this is going to get a little ugly up front, but the purpose of it is to develop a shortcut. So once we develop the shortcut, you won't have to replicate what you're seeing right now. If we can locate the vertex by averaging the x-intercepts, let's talk about that. So we have a generic parabola. We'll call these x-intercepts x1 and x2. We don't know what they are yet, but we'll find them. And the average, well, let's just write how to average. How do you average 2 numbers? You add them and divide by 2. So I know what I want to do. I want to take whatever these are and average them, and that'll give me the x. But how do I figure out what those are? Well, remember that for x-intercepts, you have to solve f of x equals 0. Okay. We're going to solve ax squared plus bx plus c is equal to 0. Well, how can we do that if we don't know what the numbers are? Oh, wait a second. We have a formula for solving this. It's called the quadratic formula. So if we do the quadratic formula, we're going to get our 2 x-intercepts. Oh, wait a minute. We need 2. Oh, the quadratic formula, it has a plus minus in it. So we could say that one of the x-intercepts is the quadratic formula with a plus, negative b plus the square root of b squared minus 4ac over 2a. And the second x-intercept would be the quadratic formula answer with the minus, negative b minus the square root of b squared minus 4ac over 2a. wait, am I saying that we're going to try to average these two things? Yes, I am. But don't let it intimidate you. Averaging is a two-step process, add and then divide by 2. So let's just handle the add first. x1 plus x2. All right, now I could write these down here with the plus in between them, but they're already stacked on top of each other. So let's think about it as a stacked addition problem. We're being asked to add 2 fractions. That's the bad news. The good news is they already have the common denominator, so that's the good news. So all we have to do is combine the numerators. But look at the numerators, that's the bad news. But here's more good news. Look more closely at the 2 numerators. These are like terms, so they'll combine and make a negative 2b. But these ugly square roots are opposites, so when they combine, they cancel. So if I add my 2 x-intercepts, the common denominator stays the same. The negative b's combine to make a negative 2b, and the square roots cancel because one's a plus and one's a minus. So adding them actually cleans up really nicely, and it cleans up even better. You can reduce both sides by 2 and get negative b over a. Now that's not part of our formula yet because we're still averaging our x-intercepts, and we have to take that and divide it by 2. So x1 plus x2 divided by 2 is that answer. Negative b over a all over 2. Well, that looks messy, but there's a way out of that. There's a couple of ways out of it, but if you ever have fractions inside of a fraction, a move that will always clean it up, and I'm not sure if we've had an opportunity to discuss this yet, but if you ever have a fraction inside of a fraction, one move you can do to clean it up is to multiply both sides of the fraction by whatever is necessary to cancel the smaller fraction's denominator. So if I multiply both sides of this big fraction by an a, then on the top I can do that. No more little fraction, leaving me negative b on top and 2 times a on the bottom. So what just happened here? We averaged 2 generic x-intercepts to locate the x-coordinate of the vertex. Well, this isn't that bad. It just says negative b over 2a. So without further ado, here's the formula for the vertex of a quadratic function in general form. The x-coordinate is just negative b over 2a. We'll do an example here in a minute. I know this video is running kind of long. Oh wait, a vertex is an ordered pair. It needs a y. Is there a formula for the y based on a, b, and c? There is. Do I know it? No. Why? Because I don't need to. I have an x-coordinate and a function. I know how to make a y. Take whatever you got for the first answer and stick it into your function. Now this looks a little intimidating. What do you mean f of negative b over 2a? I mean take the answer you got here, stick it in the function, and spit out the y-coordinate. Now we will be doing some more of this in a moment. I may do another one right now. Let me check the length of the video. I'm afraid this one has gone even longer than the previous. Not quite, but it's just about there. So I'm going to go ahead and push this video about another minute and a half. I know we're hitting the 15-minute mark, but I would be remiss if I didn't do an example. In fact, let's do the example that we just had. F of x equals x squared minus 6x plus 8. We already know where we think the vertex is. We think it's at 3, negative 1. But let's use the formula that we just discovered. The one where we got by averaging the generic x-intercepts. Thank you, Quadratic Formula. To find the vertex of a quadratic function in general form, to find the x-coordinate, you just calculate negative b over 2a. So just like in the quadratic formula, the b is the coefficient of the x term. So in that case, b is negative 6. So the opposite of negative 6 over 2 times a. A is the leading coefficient in front of the x squared. That's just 1. The top is 6. The bottom is 2. 6 divided by 2 is 3, which confirms what we said earlier. And to get the y-coordinate, and again to emphasize what this is saying, Just take your first answer and stick it in your function. Take your first answer and stick it in your function. F of 3 equals 3 squared minus 6 times 3 plus 8. But we had already worked that out earlier. It's -1, and so our vertex is 3, -1. It's actually not that difficult to do. It's just a little tricky to build, but I wanted to show you the building process. Actually using this formula is pretty quick.